When working in statistics, there are a lot of symbols that have specific meanings, and it's really important that you get comfortable with these symbols and the meanings that they represent so that you know what it is that someone's reporting to you if you read statistical references, as well as you'll know what questions are being asked of you if the symbols and the vocabulary are used within a questioning idea. Now, when we look at this with statistics, I do also have a video on the basic vocabulary of statistics, and I've put that link in the description of this video. It is important when you're starting out working with statistics, or as you go through, that you continually work towards getting comfortable with the vocabulary and getting comfortable with the symbols. And this video is representing working with the symbols so that you know the meaning of it. Let's get started. Now, one of the first things we want to talk about in the idea of working with statistics is the difference between a population and a sample. When you talk about a population, it means you have the entire set of data from your focus of your study. If you're talking about a sample, you have a subset of that. Now, when I look at the idea of some sort of calculated measurement about what I have, if I have that calculation from having the entire population, then that is a fixed numerical value for that set of data because you have the whole group. So for example, if you calculated the mean of the population, that mean is a fixed value that would be the same today if you calculated the mean of the population and tomorrow. And when we talk about some sort of numerical representation of the population, it's called a parameter. So those are population parameters. Now, if you take a sample out of the population, then you're taking a subset of it. So if you just calculate a measurement using the data from the subset, every time you reach in and then grab a different sample, you're very likely going to have a value that's different out of your calculation than the other one that you grabbed because you don't have all of the data values, you just have a subset of it. So when we find those numerical measures about a sample, that's called a statistic. So we have population parameters and sample statistics. Now, we want to be able to portray to others when we've made a calculation dealing with having all of the values, so having the population, as opposed to when we made that calculation just having a subset of the values, just having a sample. And in statistics, the symbolism helps us portray that information to someone else, and it also helps us when we're a reader of information to know whether the person that's presenting the information had the entire population or if they had a sample. Now, most of the time, when the symbols are for a population parameter, they use a Greek letter. And if the symbols are for a sample, they use a letter from the English alphabet. This differs in a couple situations, but majority of them are Greek letters for parameters and letters from the English alphabet for our statistics. Let's see a couple different ones that are used quite frequently in the beginning part of your work and then throughout all with statistics. So first off, the size. When we're trying to say how many data values that we have, if we're talking about the number of data values in a population, that is denoted by a capital N. And N for the first letter of the word number. And then if we want to say how many we had in our sample, then that is a small case N. So here's one of those first cases where instead of using a letter from the Greek alphabet for the parameter and a letter from the English alphabet for a statistic, they just used a capital N for the size of the population and a small case n for the size of the sample. Next up is the mean. Remember, when you calculate the mean, you take and add up all your values and you divide by how many there are. Now, that is the same formula you use whether you have the entire population and you're finding the mean, or if you have just a subset of the population and you're finding the mean. We'll symbolize them differently to portray to someone whether we had the population or whether we had the sample, but the formula is actually the same. So if you're using like a TI-83 or a TI-84 calculator to get this information, and you look at the screen where they're reporting it to you, they're just going to have one of the symbolisms on the line to tell you that it's the mean, and then you have to write the correct notation in your response to someone about it, whether you had the entire population or whether you had just a subset. Now, if you have the entire population and you're adding together the values and dividing how many you have, then that's a population parameter with the mean. And so they use the Greek letter mu for the population mean. And for a sample statistic for the mean, the symbolism is x with a bar over it. So you'll notice again on your calculator report, it'll say x bar equals, but if you had the entire population and you know that it is the population mean, you would write mu equals whatever that number is, because you're the one that has the information about whether you had the entire data set or just a subset of the entire data set. Now you might think, well, why didn't they use mu equals in the report instead of x bar equals? Well, the main thing is that in statistics, most generally, we do just have a sample that we're making the calculations out of, and then later on in inferential statistics, we're making estimates or we're answering questions about a population parameter based on the sample statistic that we gather. So since most generally we are dealing with a sample, they opted to use that symbol because it would be what people would have most often. Next up is the standard deviation. So for the standard deviation, if you have the entire population, your symbolism is the Greek letter small case sigma. Now note that the Greek letters have capital letters as well as lowercase letters. And so when we say that we have our lowercase sigma, this symbolism, that is for your population standard deviation. For your sample standard deviation, it is the letter S. Now, back up to the standard deviation, the formula for the population standard deviation is a little bit different than the formula for the sample standard deviation. In the formula for the sample standard deviation, there is an adjustment in the formula because of the fact that you have a subset instead of the whole data set. And so they are numbers that will be different from each other. So on a report, you will see a sigma, sometimes I'll put like a little subscript x here, and then you'll also see a line that says S, and again, sometimes I'll have a little sub x there. So you have to, if you know you're supposed to do the report for the population, look across from the sigma line for your value. And if you know you have a sample, look across from the S to get your standard deviation. And again, most generally, you're dealing with having a sample. So most generally, it will be the S that you look across for your standard deviation. Next up is your variance. Now your variance is just the square of the standard deviation by formula. You take your standard deviation value and you square it, and that is your variance. And in mathematics, if we're trying to tell somebody to square a number, we put an exponent of 2 on it. And since that's what you do to get it, that's actually what they used for the symbols to represent it. So our variance for our population is sigma squared, and our variance for our sample is S squared. Next up, proportion. Our proportion is part of a whole that has some sort of a characteristic. So it's the proportion out of the group that has a focused on characteristic. Now here is where we again are going to go away from that convention of Greek letters being our population parameter and the letters from the English alphabet being our sample statistic, because proportion starts with the letter P. And the Greek letter that goes with the letter P is pi. Now, years ago, they actually did symbolize the population proportion as pi and the sample proportion as your English letter. But so many people, not just students, but also even in people reading and writing statistical studies and all of that sort of thing, couldn't separate themselves from the thought that pi is the geometry pi, 3.1415926, etc. And so it was hard for them to take the context of pi being used in statistics as the population proportion. So the transition was made that, okay, we're going to use P for the population proportion just so we get away from that being an issue. But then if P is the population proportion, I've already used a letter from the English alphabet. What do we do from there? Well, what they decided to do to symbolically represent the sample proportion was to take your P and put a hat on it. So we call that P hat for the sample proportion, and P is the population proportion. And then the last one that I'll discuss in this video is the linear correlation coefficient. Now, the linear correlation coefficient you get when you're doing the work with linear regression. And with that, our sample statistic for the linear correlation coefficient is R. When you think about the Greek alphabet, or if you go reference the Greek alphabet, the Greek letter that goes along with R is rho. It's spelled R-H-O for the pronunciation of it. And the symbol for rho looks like this. So you have your population parameter for the linear correlation coefficient is rho, and then the sample statistic for the linear correlation coefficient is R. Now, I encourage you to make sure that you keep working on seeing these symbols and realizing what they are represented. Because again, when you read statistical studies, they may say the words, but they may just give you the symbols. And so you'll want to make sure that when you look at these, your mind associates these ideas to them. And it is something that takes active practice. So you may want to, on one side of an index card, put the symbol sigma, and then on the back of the card, write population standard deviation. And then on another card, write S, and on the back of it, write sample standard deviation. But going through that so that you can flip through them periodically and really get to be comfortable with the symbols and what they represent. And I can guarantee you that will help you immensely in being more successful and feeling more comfortable in your work with statistics.